I'll use the phrase Arctic hardened. That's very important to us. There's a lot of technology in the lower 48, and when it gets to Alaska, it just doesn't function.
Here this fall 2012, it's 11 GE 1.6 megawatt wind turbines.
While in Alaska we now have 25 wind diesel systems, worldwide there's probably 50. So this certainly makes Alaska the leader in this type of technology.
Many of the places have an abundance of wind, and so it's in many ways almost a challenge of too much of a good thing in a single source.
But none of them are actively built for the Arctic environment. So that's the big challenge that we have to overcome, is how do we install and operate these machines in our Arctic environment. AVEC, as we are known, is a utility, nonprofit electric member-owned utility. We serve 55 villages, primarily in western Alaska. All of our villages are remote. Most of them are not connected to each other, so as a result we have to have generation facilities in every single village. We of course are diesel dependent. We spend more than $20 million a year on diesel fuel, which is a very large burden for villagers to have to carry. The average cost in one of our villages per kilowatt hour is about 60 cents a kilowatt hour. That's a huge, huge burden, and that's exacerbated by the fact that they have to burn diesel fuel for heat. And so between their electricity and their heating bill, they're probably spending 20 to 60% of their disposable income.
So Alaska is a difficult place to get development done, particularly in energy. It's a technically difficult and expensive location to develop energy projects. It also happens to be a place where the market is somewhat closed because of the regulatory system and established incumbent utilities that we have in place here. So there aren't a lot of tools to gain access to that market space. There is, in our experience, a data gap, analysis gap. There are models of the electrical system here in the rail belt, but they tend to be proprietary to vendors and consultants to some of the established utilities, and when those same utilities are customers or potential customers, it does present a challenge.
Alaska has a tremendous wind resource widely distributed throughout the state, and several of our communities, especially in the remote areas, are unique in that they don't have much other local resource available. Part of our opportunity and challenge is to develop that in a way that you can really use it cost effectively and much of the time, because wind isn't always available.
Now for Alaska, with our remote conditions and our cold climate conditions, this is not always a really simple solution as it is for, say, Texas as an example, which is why a program like EPSCoR is really critical to this technology, because there's so many challenges and hurdles that project developers come across when implementing projects. Really needs an outside research entity to help push these technologies over that development curve to become deployable successfully.
In 2008, when ACEP started up operations, the Commission was probably one of the very first federal agencies that partnered with them. ACEP has been a manager of a number of our emerging energy technology kind of grants, and they've been a very valuable partner advising us on technical matters, as well as the other aspects of technology in Alaska, how well it operates.
We're particularly interested in trying to increase the penetration levels of the wind that we are currently harnessing, because we think we can displace a lot more diesel fuel than we are today. Unfortunately, the technology is very nascent in trying to achieve high penetration levels in a standalone small rural village. So it's been critical that there be an entity such as what is represented today by ACEP, the Alaska Center for Energy and Power, because they understand our issues, they understand the needs of our communities, and they actively and proactively work with us to try and optimize our village systems.
So in my experience, looking at what the University of Alaska system has done around energy and wind energy in particular, it's been very helpful in focusing on some of the issues that are somewhat unique to Alaska, particularly the microgrids in the small rural communities where you have typically a one community electrical utility where you have a diesel power plant, a relatively small community that's geographically isolated from other communities. Wind is an energy solution and one that's been pursued in many western and Arctic Northwest Alaska communities. But pulling all the technical information, modeling, integration, especially at high penetration levels that are seen in western Alaska, can be a challenge, and so the research focus at the University of Alaska on high penetration wind diesel applications, on the control systems that are necessary, and the other integration tools, I think has been very valuable in that space.
As far as the role that NREL has played regarding wind development in Alaska, it is quite lengthy and diverse, from large-scale projects such as what's now being successfully developed as the Fire Island Wind Project right outside Anchorage. NREL was involved early on, and the Department of Energy was, with some of the early site assessments and wind resource evaluations, and more recently with some of the partnership development and institutional relations. On the more remote areas, NREL really was one of the earliest front lines testing and developing technology that wasn't commercially available. And the university fills a similar role with a more closer to the ground sense of the challenges and the communities and the appropriate adaptations of the technology. So together there's been a very long, effective partnership that initially was relatively lonely in terms of a few players doing a lot of the work and advancing the state of the art. And at this stage, because of many years of commitment and notable successes and some ongoing challenges, NREL and the university are now in a very vibrant group of dynamic public-private NGO partnerships and educational research institutions and tribal and native communities. And so there's a very broad constituency that are both benefiting and advancing the technologies and deployment of the existing now commercially available technologies in some cases.
So one of the areas where the Alaska Center for Energy and Power has really defined itself is in identifying technology areas that are really in need of a little outside expertise and support to help project developers make these technologies successful. And wind diesel technologies is absolutely one of them. I recently had the opportunity to go down to the National Renewable Energy Lab and look at their new ACEP facility, which is completely designed to help with high penetration renewables and smart grid solutions. And so the work that the University of Alaska has been doing with this EPSCoR program in identifying research areas, this dovetails tremendously with the work that's being done at the National Renewable Energy Lab. Honestly, the university here has a bit of an edge up, I feel, on what the National Renewable Energy Lab has been doing, in the sense that there's many test beds already throughout Alaska, including a test bed that was recently installed as part of the EPSCoR program up in Fairbanks. Now, this test bed will have the ability to analyze and to model system configurations and to test equipment that is new equipment or pre-commercial equipment, and to help manufacturers fine-tune their equipment before it's being deployed in the field.
As an example, it doesn't matter how high functioning your water treatment plant is. If the door is open all night long, it's going to freeze and be broken, and millions of dollars will be lost. So it's that integration of the different schools of thought, different players, that we find exciting.
We are actively a part of developing their research program. We are part of the selection process for projects. We are able to provide input both at the front end and during the actualization of the project. It has been particularly gratifying working with the University of Alaska because they have been very receptive to this approach. And that's unusual for an academic institution. Typically you find that they have a bit more of an ivory tower type attitude where we know best what's good for your people. That's not the case in this program. It has been very much more a proactive process. I think that's going to be very, very productive for us.
There's a variety of funding sources and stakeholders in these development projects. And the University of Alaska system provides a technical resource, a resource that's viewed as not being biased, but being just available to get everyone the right information. And so I think it's key to the development of these projects in Alaska.
The recognition of University of Alaska Fairbanks' role in the wind diesel technology space by the granting of the EPSCoR support from DOE is really important and something worthy of continuing because it's building a program and a knowledge base that is not something that you can just turn on and off. And so there's been now a 2 to 3 year effort under EPSCoR to really start building that foundation. And with that now in place, what seems really opportune is building on that to really start taking advantage of the investment to advance and accelerate both the technology and our understanding so that it now can become cost effective based on the initial investment. It's time to really reap that investment with the outcomes from a long-term commitment.